Hello, good morning, everyone. I'm glad to welcome you for this BIM Africa event, one of the most important events regarding BIM in Africa. My name is Bertrand Menard, and I will present you our BIM experience in Morocco. I first take the opportunity to thank the whole team who devote themselves into this well-organized and professional event. As I told you, I'm Bertrand Menard, and I'm French native, and I will do my best to be well understood despite my wonderful French accent. So this event is called 10 Years of BIM Experience in Morocco, Africa. We call it the BIM Maturity Across Construction Project in Morocco. The first part will be dedicated to an introduction, which will contain some presentation of myself, of course, and also my company. Then I will present you some example of BIM modeling on early stage first, then on concept design, then on execution works, follow-up, and then on maintenance with as-built modeling. And we will finish this show with a conclusion, sharing my vision and our perspective for BIM in Morocco. So let's start with an introduction. So let's introduce myself first. I'm Bertrand Menard. I grew up in Paris, graduate from an engineering school in 2000. In 2003, I entered the company OG International in Paris as a low current project manager, working mainly on Middle East countries. In 2007, I entered OG International Morocco as a design coordinator. Then 3 years later, in 2010, I became a project manager. In 2016, I start working as a design head manager to manage the whole design team of the Moroccan office. And since 2018, I'm now the business development manager of the company. So now concerning our company, OG International Morocco. We are a subsidiary from OG International, who was created in August 1979, initially specialized in upper-class building for Middle East clients. The Moroccan subsidiary was created in 1995 to be involved in Twin Towers, the first high-rise building in Casablanca, Morocco. Those last year, we delivered some various projects, such as a residential, industrial, or hospitality project, and also some complex building, such as a great theater and other project I will show you later. We work in several countries across Africa. We work in Gabon, we work in Senegal, we work in Sierra Leone, Ivory Coast, work in Chad. And our company is split in two halves. We have, as I told you, we have 80 workers. We have half workers working in Casablanca office, mainly focused on technical consultancy service, design office, and the other half is directly on site to work as a construction management or work coordination. So we can provide services such as quality assurance, quality control, technical audit, due diligence, project management, construction management, design management, BIM management, of course, project owner assistance. So now we'll talk about the start of BIM in our company with our BIM main step. And we have a nice storytelling about our beginning with BIM technology, because in 2009, a private client back from the United States requested us this brand new system, brand new technology for the design of his villa. So we have to buy some equipment, we have to buy new software in order to answer to his request. To be honest, the beginning was not so easy because we suffer a lot, because we have to work out of our comfort zone. 1 year later, we put in place the BIM core team with one specialist per trade. In 2012, we were maybe one of the first in Morocco to start using BIM in concept design for a standardization of a new hotel brand in Morocco. In 2016, we start working on the Grand Théâtre de Rabat as an owner assistant. We will talk about this later. The first project using the scan to BIM technology, we will develop further. And in 2021, we can say, and we can be proud of it, because 100% of our workers are familiar to BIM. We mainly work with Autodesk product, Revit software, and all 2021 and all previous version. And we also work with BIM 360 for works coordination. So now we will talk about BIM on early stage, which can be used for two main subjects. The first is design competition, and the second is real estate marketing. Let's start with design competition. So this video is a video of a private villa for design and build competition. I decided to show you this video to show that you can model very fast the model on a specific video clip. This video shows the result of only a few hours modeling, and the good point is that the model will be kept on the next stage to receive MEP networks and so on. Before BIM, people used to create 3D models as an empty box, then develop 2D concepts that may not correspond to the original 3D model. With BIM, you can capitalize the time you spend on early stage with your 3D model. So the second point is for real estate marketing, because even on early stage, you can market your real estate, because you can develop the model by adding some materials, reference, in order to modify their aspect, which means that the realistic view will include matte or shiny appearance to describe what the client will see after the project delivery. So this first example is an hotel bedroom. The second example is a hotel restaurant, including furniture, and you can see how the light is reflecting inside the room. And third and fourth examples are mechanical networks and meeting room. So realistic views are very astonishing, because it can be considered as a real photography. And for me, it's a real added value when you market your building. Then we can move forward talking BIM on concept design. For this third part, we will talk about BIM on concept design, which is maybe the most known use. We will show two interesting and different examples. So the first example is on CFC Tower. So for this reason, I put the CFC video timelines in order to show you this high complex building. This building is the first one made on the old Omfa Airport area. This is the first high-rise building in this new business area. This building is 25 floors, approximately high 110 meters. The project started in 2014 and end in 2018. The architect is Tom Main, sorry. Tom Main is a US citizen and founder of Morphosis architectural agency. So regarding this tower, we were awarded as a technical consultancy services with Tractable Group. We were in charge of technical design, including BIM LOD 350 and technical synthesis, but also clash detection. So there is some picture of our modeling regarding the structure and the MEP. This model was created 5 or 6 years ago. So we also want to show you some synthesis drawing that can be extracted from the model. It's important to underline that even you have the BIM on the project, every time you need, you can extract 2D drawings. Anytime you need a paper drawing, you can extract. Anytime you have a meeting and you want to explain something to a contractor, for example, you can extract a drawing with all required information and you can easily have access to this information. So with this kind of drawing, you can easily animate technical meeting, and it's very important to say that despite 3D model, you can produce 2D old school drawings for any kind of use. So this is a kind of synthesis details you can easily add on the same view, on the same drawing, section, elevation, and 3D view in order to show, for example, all MEP networks above false ceilings. And you can easily understand that with BIM technology, the technical synthesis is much easier. The next use on concept design, the next example is hotel brand development and concept standardization. The objective is, we have two objectives in this project. We had two objectives. The first one was the concept standardization, and the other one was to prepare lump sum quantity for every next hotel to have an efficient call for tender. So this view shows the main facade with all train modeling. Then we present you the back facade. You can see all technical equipments, which means mechanical system on the roof, including solar panel on the left side. So concerning this concept standardization, the idea was to split the project into three parts. The first part, which is the main part, which is bedrooms, because this is clearly part of the program. This is one thing which will not change depending the position. We will keep the same part of construction. So it's common to all development. The second part, which is called the base in blue, it's substructure. So it has to be adapted to each parcel according to the soil survey, to geotechnical survey. And the last part is the extension part in red, which is also adapted to each parcel according to the available surface, which can be turned for specific activity. So now I present you one picture extract, which is a section of ground floor with architectural details, but also furniture. You can see restaurant, back of house, and all require rooms. Next, I show you the drawing extract from the BIM model. You can see that you have all required details, furniture, and so on. Then we show you the structure model. We decide to show also some technical equipment because it's part of the structure, with substructure also, with some basic, you can see on the back, some basic foundation. So this is an extract from both structure and MEP model on technical shaft and horizontal distribution, horizontal networks. I would like to precise that thanks to BIM, we can well organize our technical shafts. Most of time before BIM, we used to think about technical shaft, but not so much. We just double check that the size is enough to put all shaft, cable trays, and so on. But we didn't think enough on the maintenance point of view. Thanks to BIM, we can think about access, how maintenance team can have access to manhole, to hand command, and so on. So it's very important. And thanks to BIM, we have very efficient technical shafts. The next view is the standard bedroom model in order to show you the kind of product. We can't talk about the name of the hotel, but it's a 3 or 4 stars hotel. And you can see the model with furniture and all architectural details. Then I present you the 2D drawing, still extract from the model. You can check all details regarding floor definition, furniture, plumbing equipments, doors, and even curtains. And all technical references are still linked into the model. So now I will show you some quick example of some surface table which can be extracted directly from the model. With BIM, once the model is well and precisely defined, you can easily extract the quantity you need in order to provide bill of quantity for your call for tender. This quantity extraction is also available for any trade, which means architectural trade, of course, for painting and so on, but also technical trade. If the BIM model is well organized, you can easily obtain all quantity, integrate modification if you need, and extract very quickly all quantity for lump sum contract. So this important, it's very important to understand that in Morocco, even in a contract point of view, the bill of quantity is not the most important piece of the contract. Sometimes you can have trouble with contractor because the quantity are not well calculated. Thanks to BIM, we can double check quantity and we can decrease the risk of discussion about this. So inside the BIM model, you can, of course, add any required technical details. For example, some removable walls concerning 3 conference rooms, which can be turned into 1 large conference room. So you can see required details extract from the model, the 2D drawings and the model. Another technical details can be, for example, false floor or technical floor. You can extract from the model. So after explaining our experience on early stage and on concept design, now I will present you BIM on execution works follow-up. We will explain how we succeed to implement BIM on execution phase on such impressive project called Grand Théâtre de Rabat, that we can translate at Rabat Great Theater. Let me show you the project. So this project is very impressive. For this reason, I decide to show you some drone video we made maybe 2 or 3 years ago now. This video has been shown to show the complexity of the building. It's amazing how complex is the building. This building is kind of piece of art because there is no straight lines, there is curves everywhere. So this project is located in Rabat. The concept has been done by Zaha Hadid. Zaha Hadid is an Iranian architect, worldwide architect, maybe we can call it artist, who always love to challenge people who work on her project. She loved to challenge engineer because on such project, you keep learning how to build it until the completion of the project. So every day you have to challenge yourself because there is innovation you have to put inside. So for years, because I have an engineer background, for years I was thinking, oh my God, this kind of building is too complicated. But now I understand what this kind of architecture brings to engineer. It really helps people to improve their level, to improve their skill. So in this mission, we were involved as owner assistants, which includes execution synthesis, class detection, scan to BIM, and also BIM for maintenance. So this is the structural model, crazy model. And as I told you, there is no straight lines, only curves. And inside the model, there is a very huge auditorium without any columns, which is a structural innovation. You can see one picture from the architectural model. You can see all kind of boxes we put into the external envelope, all specific rooms, and then the MEP model. So you can easily understand what BIM brings us in order to have an efficient execution synthesis. In this picture, you can see HVAC networks in red, plumbing network in green, high current in blue, and low current in pink, I think. Now, there is some view where we compare the BIM view to the real view. This view is from the projection room, from the fourth floor balcony. The second example is still the same kind of comparison between BIM view and real view. It's from the auditorium, second floor balcony. As I show you for CFC, this is the basement synthesis 2D drawings. This is a partial synthesis between architectural trades and mechanical networks. You can see the result of clash detection and the result of our proposal or request to the local architect in case of dealing compromise. Which means that in 2D drawings, every time we extract 3D view to make things much easier to be understood to the architect or to the owner for better explanation. And then the clash follow-up. This is the table we use for clash follow-up. And this table include for per columns family trade. It includes also clash explanation. It includes location. It includes 3D pictures. It includes who will be in charge of coordinations according to the area in case we have some different coordinator on site. Of course, we put the resolution, the answer we provide, and also we decide to add a color code for a quick view when you can see a clash in progress, a clash which has been resolved, done, or clash which are impossible to solve, which means we have to talk to the architect to make a compromise and maybe to adapt some file selling position or something like that. A kind of compromise to modify the design. Then, after execution synthesis, we will talk about scan to BIM. Scan to BIM in this project was maybe one of the first scan to BIM experience in Morocco. So you have to understand that scan to BIM is a 3-step process. First, it's a as-built scan with 3D equipments. It's Faro scan, for example, up to 350 meters distance. And this scan will produce what we call point cloud files. We'll give you some example in few slides. And this kind of 3D scan is nowadays a common or typical topographic equipment. And once we produce these point cloud files, we can transform it into a Revit file. And once we have the as-built Revit file, we can make comparison with the original Revit modeling. And once we have the comparison, we will adjust the tolerance per each trade. Why adjusting the tolerance? Because finally, the gap can be a big trouble or a small trouble according to the trade. For example, 10 centimeters gap can be acceptable if we are talking about some cable trace position above a false ceiling. But if we are talking about concrete, for example, 10 centimeter is a huge gap. So for this reason, we make comparison and then we define the tolerance per trace. I will show you an example in few slides. So concerning the scan, this is a kind of schedule because I want to explain how we have to schedule the scan of a site in progress. When the site is empty, it's very easy to scan and it's very quick. But because we are working on a site in progress, we have to schedule all scan. We have to schedule it according to scaffolding position. We have to schedule according to large equipment position. So for this reason, the scanning schedule is directly linked to the progress. So for this first use, it was very hard to schedule everything, and we have to explain why we decide to scan this area and not this part. For example, the slide show per floor. For example, this is the ground floor. The green part has been scanned, and the blue part has to be scanned. And we explained to the owner that there is still some scaffolding on site. And for this reason, we have to wait the end of the equipment. And once this equipment is removed, we will make the end of the scan. So this is the result of the scan. This is 2D picture extract from the file called point cloud file. Because as I told you, the point cloud file is a 3D picture, 3D model, but only with point. It's very impressive. And this is another picture extract from this kind of point cloud file. So this is the result of the comparison and gap identification. We compare the as-built file and the original BIM model. On this slide, you can show the result of the comparison. And regarding to the concrete work, you can see the tolerance we decide according to the contractor and also to the technical norms. In this case, we decide 3.5 centimeters as a maximum tolerance. And you can see in red the unacceptable area. And on this project, the scan-to-BIM technology was very, very useful because this is no plain area. This is a huge and large area with complex curved lines. And thanks to BIM, we can check the result of the work, which is very useful. So after explain some BIM on execution works follow-up, we will talk about BIM for maintenance. BIM for maintenance is today in Morocco the final use or the final objective concerning construction in So the first example I'd like to show you the Chica Lagoon Resort in Nador. Nador is a city in North Morocco, close to the Mediterranean Sea. In this project, we start working in 2014 as a construction manager. And then we had an extra request from our client to improve execution synthesis and also to produce an as-built model for maintenance. So this hotel is owned by the ONCF, which is the national Moroccan highway company. And those last years, they decided to model all their real estates in order to improve maintenance and also to centralize the necessary follow-up. So you can see the real view of our BIM modeling. So this slide shows simply how we have all required information for maintenance. We had informations on different technical equipments. This slide shows extra information we had on fan coil units, HVAC equipments. In this case, you will have all post-construction actions, which can be filter replacement, any comments, product reference, maybe the name of the technical guy, of the maintenance guy. You can easily add action and also put reminder you want. The second and last examples we show you is Jamai Palace in Fez. This palace is still in progress. And on this project, we had the same story as on Marchica Lagoon Resort in Nador, because we were first involved in construction management. And then the client requests us some help for execution, synthesis, coordination, and as-built modeling. So this slide shows the real view and the corresponding modeling. Then you can see the architectural model and the structural model. So now for me, it's time for conclusion after different steps we had on this presentation. It's time to show you my conclusion about BIM and our perspective. As a perspective, as a conclusion, I would like to say that I would like to spend a few minutes on McLean curves. McLean curve is very effective, it's very efficient curves that show you what BIM brings us. It compares a typical effort you can see on pink and the EPD or BIM effort, integrated EPD. It's integrated project delivery, which means 3D integrated project on blue. You can see also the black line, which is ability to impact project. It decreases the more you progress from pre-design to construction. And also the cost of design change, which is the red line. And of course, the later you want to change the design, more money it will cost you. So Patrick McLeamy is an American architect. He's an ex-chairman and CEO from HOK. HOK is a worldwide architect and engineering office. So you may have seen this graph before. And the key point is that architects expel their effort at a time where design change are relatively costly. And thanks to BIM, we will reduce the cost of design change. With the BIM, finally we produce the same effort, but on the early stage, which means that we will think about how to improve the design, how to put some modification, some change in our design, but on early stage, which means that it will cost less. So for me, this graph is simply the best way to convince people to use BIM. So after 10 years or maybe 12 today, we have delivered maybe approximately more than 12 projects in Africa or Middle East countries. We modelize a lot of square meters, more than 100,000 square meters. We realize that more and more countries now request honor to send a BIM model for building permit. It happens in South America, it happens in some Middle East countries, and maybe it will come soon in Morocco. We actually work on 4 projects on BIM in Morocco. And to finish, I would like to say that I'm making some business development, and some clients like BIM. Every time I present them BIM, and they used to say, okay, I like the BIM, but how much it will cost more? And I like to answer them that it will not cost more, because today in OG, in our case, because we have experience, today equipment is already integrated in our fees. It's amortized already. Software, everything is now already amortized. So BIM is not an extra cost. And thanks to BIM, we win time and we win money, which means that today's it costs the same price. And maybe in 1 year, in 2 years, we will spend less money using BIMs, which means that anytime I will talk to a client, I will tell him we will make it your design for this. This is the price for BIM, and with 2D design, it will cost you more, because it's a common benefit. We spend less money thanks to BIM, and it's clearly shows that BIM for me, it's not the future of engineering. It's present time. BIM is now. Thank you once again to the BIM Africa team, and thank you to everyone who spent time online listening to my presentation. I wish you a great day. Bye-bye.